what happens is my other one, I have these people that like ask me a challenging question, and I'm not real good on the spot with that. If you ask me a question that's kind of like out of the ordinary, I have to go. I can't just like pop that out. Yeah, that's all right. Okay, so let's go over. This is the contingency table and Simpsons Paradox homework to make sure that you have a good understanding of that. Furthermore, I think that Simpsons Paradox, you could get caught up in that, and you might think, oh my gosh, this is a really hard mathematical thing. I don't understand what's going on. But I want to today summarize for you really what you need to know with Simpsons Paradox. And it's not as mathematical as you think. The mathy part, I don't really care about you knowing the details of that. So, first thing, this was your homework. Let's talk about this. So I chose to do my values on this top to bottom. So I chose to do mine with this blue direction. So I went by ownership. So those that own, so I went 28 over 188, and then those that do not own, 160 over 188. Now, that means then if I choose this direction for my marginal, then I'm choosing this direction and this for my conditional. Alright? Now, some people may have done that problem the other way. Did any of you guys go with this for your marginal? You went 93 over 188 and then 95? Did you go that direction? If so, if you go that direction with your marginal, then what has to happen with your conditionals? They go sideways just the same. Alright. So now, after I know that this is saying 15% of all the people own a smartphone, and this says 85% of all the people in the sample do not, then I'm going to compare the conditional ones to that. So I'm going to see if you are employed, it's this right here, 27%, and you own a smartphone, how does that compare to owning overall? So what could you say about being employed and owning compared to owning overall? It's more. Very good. So being employed, you have a higher rate of ownership than just owning a smartphone overall. Okay. Good. And so I'm comparing, I would compare this 27 to 15, or I would compare this 3 to 15. But I would not ever, I don't want to compare 27 to 3. Okay? Alright, so next, I don't know if you want to do that now or just okay.
Wait, so the 27, you say more than often the employee owns a smartphone.
Correct. Then ownership overall. Yes. Okay? No. That's correct. Sometimes you just have to like say it. Okay? Okay. The wording issue is this. People that are employed own a smartphone at a higher rate than just general ownership overall. Okay, yes. No, that makes it, there is a relationship because something's happening. Employment status is affecting the rate at which you have a smartphone, so they are related. They are connected. They are influencing each other. Okay. All right, so then my summary. Remember, my summary is going to contain 4 things. First, I'm going to say if they are related. If they are connected and affecting each other, then you say there appears to be a relationship. Don't tell me there is a relationship. Okay, appears is a nice, wigglier word. And in statistics, it's virtually impossible to quote-unquote prove something because that would mean you had every piece of data everywhere. Okay? So we can just see from our data that there appears to be a relationship between employment status and smartphone. Alright, so then I give 2 facts. My facts I chose, I circled in red. This one here, which we already said, if you are employed, then you have a higher rate of owning a phone than owning a phone overall. Okay? And then look, I stated the number. 27% versus 15%. So I put a specific number in there. All right. Then my second fact I said was this one. This one actually, I think word-wise is kind of confusing, but anyway. And you have 4 to choose from. You have 4 facts to choose from. You can choose from basically any one of these numbers to make a statement with. Okay? I chose this one because it's a big number. I was like, okay, I think I should probably do something with that. So, if you are not employed, then what are these people doing as far as phone goes? This group is what? Not owning. Okay, good. So if you are not employed, then you are not owning a smartphone at a higher rate, because 97% are not owning a smartphone compared to 85% overall. So here's how I worded that down here. Not employed, so from here, not employed people do not have a phone. I guess as much, is probably what it was supposed to say, as much. Oh, wait. I don't know what that says. It is at a much higher rate. Oh, do not have a phone at a much higher rate. Yes, that's right. And so, than having a phone overall. And then I put the actual numbers. And summary sentence makes a statement about independence or not independence. Therefore, employment and ownership are not independent. Okay, remember, here's what your brain is thinking. Here's you in stats, and here's what you're thinking. Okay? You're going like this. Employment and phone are affecting each other. Since you think that they are affecting each other, then they are connected. If they are connected, you know, if they are connected, then they are not independent of each other. Okay? Because they are connected. They are tugging on each other. Right. Okay. Next. This is the Titanic. I think I kind of led you guys down this vertical direction because it said we want to compare class with survival. So we go with the totals. This column here is going to give us this what? What's this that I'm circling? That's going to give us our marginal distribution by class. So I get that by this. So for 322 over 2206, tell me in words what 14.5% means.
Total amount of total percentage of the whole.
Perfect. That's right. So this means 14.5% of all of the people on the Titanic have a first class ticket. Okay? So we know what's happening overall. This is the rate that they are on the ship. 12.5% of all of the people on the Titanic are second class, and so on. 32% of all the third class are that, and 41%, so most crew. 41% of all the people on the Titanic are crew, so I can wait on all those other people. So, now then we go with the conditional. Conditional is done in the same vertical direction. These are the people that died. So out of the 1,503 people that died, I want to learn about how they are related in class. I personally kind of used this set of data to make my comparison to kind of, relate. They're the inverse of each other. in essence, you could have gone with these numbers, the saved numbers as well. So, what am I going to compare this 8% to? Good. I'm going to compare it to this 14.5, and because this number is lower than the first class overall, and what am I saying about the first class members that died? They're dying at a lower rate. Good. The first class ticket holders are dying at a lower rate than they are on the ship. Because here's the thing. If people were dying at the same rate, then this number would be the same as their rate on the ship. 14.5% would have died because there's 14.5% first class people on the ship. Okay? Alright. So then of course I'm comparing this 11% to 12.5%. All right. So I personally noticed that, what do you have to say? I highlighted it in yellow here. The first class and the second class survivals, or they were dying at a what comparison to overall? Good. I noticed that first and second are dying at a lower rate than they were expected to, if they were equitably dying. Okay, and then third and crew I have them in green here. So third is 35 compared to 32, and crew is 46 compared to 41. So they are actually dying at a what? Higher rate. So when I chose to make my statements, I kind of was goody two-shoes and wrapped 4 statements into 2. We didn't have to do that, but I kind of went above and beyond. How many statements could you have chose from to make? 8. So don't tell me, could I say this, could I say that? Yeah, I'm going to have to grade and see if you made one of the correct 8 statements. Okay? And so, here's the thing. Does it appear as though classification and survival is connected? Yes. So, there appears to be a relationship between classification on the Titanic and survival. Okay, then here comes, so that's your relationship sentence. Here comes my 2 statistical support sentences. And I remember I rolled 2 facts into 1. I said this: first and second class lost their lives less than expected overall. And then here's my facts. This is first, this 8% to 14.5%, that's the first class data. And 11.5 versus 12.5, that's the second class data. And you know what, I use this word, and you might see this in text, and maybe you already know this, respectively. Meaning, I put them in the same order. First to first, second to second. Is that required? No. All you had to do is just give one of those. Okay, additionally, I said third class and crew lost their lives at a higher rate than expected. And then I gave the 2 data. This is the third class data, and this is the crew data. So, in summary, so here's my summary sentence about independence or not. Therefore, class and survival, they're connected. So they are connected to each other. They are not independent. Okay? This is your visual, me putting my hands together. They are connected. They are not independent of each other. All right. Questions here? Yes, ma'am. Sure. Okay. Oh, we're about to do Simpsons Paradox. Can you get on that?
Yeah.
Okay. All right. So now let's go over these Simpsons Paradox problems. And actually, what I want to do is summarize kind of exactly what I expect you to get out of Simpsons Paradox. Okay. So here it is. We have talked about happiness going on and adding fractions inappropriately and yada yada yada. But technically, here's what I expect you to get out of the Simpsons Paradox problems. That you basically look at 2 sets of data. You will be looking at a set of overall data where things have been combined. And you will come to a conclusion based on that combined data. And then you will be given another table or another set of information where the data is separated. So the data is separated by, some other variable. So maybe, like in the baseball example, it's separated by against left-handed pitchers and against right-handed pitchers. Okay? And what happens is the conclusion you come to with the separated data is different from the conclusion you came to with the overall data. And then that is called Simpsons Paradox. Yes?
Separated, normally more.
Good question. Separated is correct. The overall is wrong because what happens, the way they came up with the overall data is if they did it by adding fractions with unlike denominators, then that's wrong. If they did it by adding percentages are actually okay to add, and we'll talk about that in a second. So that's good. Basically, if you're coming to a different conclusion, then they did the wrong way here, and the overall is wrong. Okay, let's now look at an example of that. So did I say anything here that I'm expecting you to tell me what fractions they added together wrong and all that stuff? No. This is the general concept I want you to know. So here's this. I think we went through some of this yesterday, is that correct? Oh, we did? We went through all of it? Okay, well, I'll go quickly through it. Basically, this top one is the overall data. And they got it for the total deaths. And when we did it overall, we could see that the conclusion was that the Caucasian defendants lost their lives at a higher rate than the African American defendants. So the Caucasians, that's what this C stands for, Caucasians were sentenced to death at a higher rate than the African Americans. Now, let's look at this when we separated it out. What was the separating factor here? What was the trait that they then split the data up? Good. They split it up because of the victim's race. So these two yellow ones went together. Caucasian with a Caucasian victim, Caucasian defendant with an African American victim. And then you can see these values separately. But these are now in percents. So tell me, what is the denominator for a percent? 100. So when you have something in a percent, they have made common denominators. You know that? That's what a percent is doing. A percent is turning a number into having a common denominator of 100 on the denominator. So then can you add percents together? Absolutely. So then that's what happens is when we added the Caucasian percents together, we got 11.3%. And when we added the African American percents together, we got 25.7. So therefore, in actuality, what happened? It's showing that the African Americans are being sentenced to death at a higher rate. Okay? Which one is correct in these two cases? Which one's correct? The separated one is correct because of this right here. The way that they got the overall numbers was by doing this. 53 over 467 plus 0 over 16. And here's what their sum was. They just added it up. 53 plus 0 is 53. 467 plus 16 is 483. And hopefully you learned that in 4th grade. That's not the way you can add fractions. That's what made that overall chart wrong. Okay. So then here's what your conclusion looks like. The question is this. Is there a discrepancy in the results? What do I mean by that? Is there what? Is there a difference in the conclusion for the overall versus the conclusion for the separated? And the answer is yes. Because in Table 1, it appears as though the Caucasian defendants are sentenced to death at a higher rate than African Americans. But in Table 2, African American defendants are sentenced to death at a higher rate. So you had different conclusions. This is called Simpsons Paradox. Alright, let's go over this last one here. Many of you were confused about what all's going on in this. And let me kind of tell you my feeling on this is a really neat example. If finance and business and economics interest you, and you're good at that kind of thing, then you would benefit, or it'd be a lucrative job for you in the business world to focus on the statistical part of your economics. And knowing something like this is going to help you. So let's talk about what happened here. We have two sets of data from two different years. 1983, and technically this is 2010, but I called it 2013. So 30 years apart, we have the 1983 data and then 2013 data. Okay. So what happened was, the first questions that I go through is for you to tell me overall what the unemployment rate is overall for two groups combined together. The high school dropout group combined with the college graduate group, I want to get an overall unemployment rate. So I did not expect you to be able to come up with this formula here. I would never ask you to do that. In fact, this data came from reading the paragraph and reading the article. So I got those facts from the article, okay? But I did expect you to do the math and come up with the value, and that was a unemployment rate for those two groups combined of 3.62%. Good? Now, 2013, I did a formula also. The unemployment rate for those two groups in 2013 was 3.12%. So question number 2, when you look at the combined categories, which year appears to have a lower unemployment rate? 2013. Very good. So guess what? Politicians are definitely showing you this data here. They want to say, hey, you think that the recession is bad now, but guess what? It's okay. It's all good. You know, we fixed it a lot faster and better than they did in 1983, because the unemployment rate in 1983 during that recession that was going on there, of which the Republicans were dealing with that, was a higher unemployment rate for those two groups. And then here, Democrats are saying, woohoo, look, overall, we only have the 3.12%, and they have the 3.62% overall. Okay. But we know that you need to look at the separated out results. So, number 3. When you look at the high school dropout rates and the college graduate rates separately, which year appears to then have the lower employment rate? That data comes from the picture above, so let's look at that. Here it is. This is what does this say, this 13.6% here? Okay, yeah, it is high school dropout. So this is saying in 1983, 13.6% of high school dropouts were unemployed. Okay, we'll compare that same number in 2013. What percent of high school dropouts are unemployed? 14.9%. So which is worse? So 2013 is worse. Okay, and in this one, by the way, remember with the overall, it looked better. Okay, but when we looked at it individually, it's worse. Okay, let's look here. This is college graduates. So in 1983, 3.6% of college graduates were unemployed. In 2013, 4.9% of college graduates are unemployed. So therefore, this one is, 2013 is worse. So this is Simpsons Paradox, because when you looked at the overall results, here was the overall results, it appeared as though the unemployment rate was better. However, when you looked at the high school dropouts individually and the college graduates individually, in fact, 2013 was worse. So then my summary down here, what is making this discrepancy? This discrepancy I'm referring to is the overall versus the separated differences. Conclusion, Simpsons Paradox. You can't add across the variables with different fraction denominators, because that's what happens to do this. See here? These amounts are weighted differently. What percent of high school dropouts were there in 1983? What's this? In 1983, what percent? 20%, 1/5, versus 1/10 in 2013. So, do you see this is weighted differently than this? That's what's making the sum skewed in a different way. Okay, so that's it. All right, let's go ahead and go over the warm-up. So pull that out.